All right, so welcome to the course. So what is Combine? Combine is a new framework from Apple for doing functional reactive programming on iOS and macOS. It can be compared to frameworks like RxSwift or Reactive Cocoa, and it prescribes modeling application logic as streams of events and operations on those events that transform them in order to implement whatever features your application requires. So what is functional reactive programming? This paradigm, often abbreviated FRP, prescribes using these streams of events to model your application logic and derive the state of your application based on the result of these streams. And as you start to model these streams, you'll start to notice that you can extract new behaviors fairly easily by tapping into existing streams that your application is producing. So if you think about object properties changing over time, those can be streams, or a user tapping on a button or dragging something around, those can be streams. Network events coming back down or notifications firing on your device, those all can be streams, and you can model all of them with FRP. Now, FRP frameworks provide the operations or operators that allow you to stitch these things together and transform them in order to get the result that you require. If you've already used RxSwift or Reactive Cocoa, then you're going to feel right at home with Combine. Now, it focuses a little bit less on the UI binding side of things, but otherwise is a fully featured FRP framework and provides all of the familiar tools that you probably are familiar with those other frameworks. It's also a fully supported framework from Apple, which means it'll be more tightly integrated into Apple's own frameworks and UI paradigms, and it will be supported going into the future. You'll also find that probably lots of projects and other developers will start adopting Combine over these other frameworks because it is a fully featured and supported framework from Apple. If you haven't used Combine yet, that's fine too. And you'll probably find it a little bit complex and hard to understand at first, and that's totally okay. This is a common criticism with FRP frameworks. They can be a little bit hard to grok at first, and learning them can feel a little bit daunting, but that's why we're here today. So before we get into the specifics of Combine, let's talk a little bit about the benefits that you'll get from taking this course. Okay, so why should you take the time to learn Combine? What's the benefit? Well, Combine can help you reason about asynchronous programming at a much higher level than is possible with the traditional approaches. If you think back, how we used to do it before was we'd fork threads and have to, manage multi-threaded programming, which is actually pretty difficult. And then we have higher level things like queues and blocks. And in the iOS and Apple ecosystem, you have target action. So you have selectors and you can invoke things that way. And you also have key value observing. So you have all these different tools in your tool belt for dealing with asynchronous programming, but they all sort of sit at the same level, more or less. You've got threaded programming, which is pretty difficult, and you've got dispatch queues, and then you have like all the other high-level things like operations and key value observing. Well, Combine sits at a level higher than this. It lets you reason about them as first-class concepts. Asynchronous programming is just by nature part of the game that we're in. And so making this a little bit easier, a little bit more first-class means that we can avoid things like lots of nested callbacks and completion handlers and things like that, which can be a little bit cumbersome to work with. Okay, so why learn Combine over things like RxSwift or Reactive Cocoa? There's actually lots of community support for Reactive Swift and RxSwift and Reactive Cocoa and all these. And it's worth noting that people are successful at delivering applications and building sophisticated applications using those frameworks. But because of its staunch different style from traditional application development, some people tend to love it and some people tend to hate it. So if you're working on an application and you, say for a client, or you need to hire a team, you're going to have to make the choice, is RxSwift or one of these other frameworks a rational choice to make? And that is a choice only that you can make, a judgment call that only you can make. But it is worth noting that there are plenty of folks and plenty of teams that will only start taking this seriously now that it comes from Apple, even though these ideas have been around in other platforms, in other languages, and have been brought to the Apple ecosystem. So it's worth noting that while RxSwift and Reactive Cocoa and those paved the way, it's worth giving them some respect and understanding that there's some history here But I think that Combine is probably going to be the more popular choice for iOS developers because it comes from Apple, because it will be a supported, more mainstream framework. So this leads me to another question. Is this better than imperative programming, this sort of declarative, event-driven design? And that's a judgment call. There's no really good answer to that, but it does change how you write applications. It does introduce features and things that are just intrinsically supported in a system like this. It's easy to bring in multiple streams of events and stitch them together and get the result that you want. And so an entire class of bugs that resolve from inconsistent state in your application or multi-threaded event handling that is been improperly configured, all those things kind of go away. And so it avoids an entire class of bugs that are common in traditional application development. Now, that's not to say that using Combine is going to make you write multi-threaded code in a bug-free way. That's not at all what I'm saying. Instead, what I am suggesting is that you will avoid a whole class of bugs, but you will probably have to deal with some Combine-specific gotchas in the meantime. So reactive programming is a paradigm shift, and you're not going to learn it overnight. It can often be obtuse at times. There are things that make it a little bit hard to debug. It's really difficult to set a breakpoint where you want it because you kind of set things up ahead of time and let it play out. And so it's a little bit harder to understand at first glance. And we'll do our best in this course to learn the tools and techniques for identifying problems and addressing them. But it is something worth noting that is definitely a paradigm shift, and sometimes it can be frustrating. Another thing I want to mention is using Combine doesn't mean that your entire application has to change, and every single method that you use that would otherwise take a completion callback should use Combine instead. And you can pick and choose and use it where it makes sense. You can use it in one area of your application just to try it out and see how it works. I do think it's important to validate this with the rest of your team to make sure it's a style of programming that everybody is comfortable with. But I do think it is worthy investment. And there's nothing saying that you have to go all in on a framework like this and make it change the entire world. You can use it for small pieces and just get the benefits that you want. And the last thing I want to mention in this section is that Apple is going all in on Swift UI and the declarative nature of programming, and Combine fits right in that worldview. And so I think this is a good time to adopt Combine, even if you're using UIKit or developing on the Mac, because it is a common, consistent framework across all of these platforms that avoiding the UI part of it is a declarative way of describing your application's streams of events and how you can pull behaviors out of them over time. In this course, I will start from the very basics so we have a solid foundation to build on. In each module, you'll be able to download the starting project or playground so that you can follow along, and you'll also have access to the completed products, so in case you run into an issue, you can compare your results with the completed one. This course will use Xcode 12. While most of the examples will work with previous versions of Xcode, I encourage you to make sure that you're running the same version of Xcode that I am, which at the time of this recording is Xcode 12.0. You can download this for free at the Apple Developer Portal, and I'll have a link for this in this module. I'm going to assume that you have a working knowledge of Swift and general app development. And while we will build a few apps in this course, we're not going to focus on the UIKit or the Swift UI part of building applications. Instead, we're going to focus more on the Combine specific parts and a little bit about application architecture. This course is broken down into separate modules, each of which is going to build upon knowledge gained in the previous sections. So while you're free to skip around, just note that you might miss on things that we've covered in a previous lesson. If you have any issues with the course, the site, or the examples, or if you just need additional assistance, feel free to email me at ben@ficklebits.com. So a quick note about the sample code. Many of the modules will use Xcode playgrounds to explore new concepts, and we will also create a few full-fledged projects. You're strongly encouraged to follow along and type the code as you see it in the course, because the practice and repetition is what's going to really drive this home. Each section also has starting and ending states, so make sure that you start from a fresh state, a known state, for each module. When you're using Xcode Playgrounds, I'd advise switching to the manually run setting, because sometimes you'll have to work out the Combine specific syntax before you really want the compiler to tell you what's wrong. By switching to manually run, you're going to avoid most of the issues you would commonly run into when using Playgrounds. And then when you're ready to run, you can either click the play button in the toolbar or hit Command-Shift-Enter, and that's what I'm going to be doing throughout this course. Okay, so let's get started. You're going to get the absolute most out of this course if you follow along through each module, typing out all of the examples, and follow along in Xcode as you watch the course. If you get stuck, you can always refer to the completed examples, and of course you can always contact me. But some of the things may not make sense at first, but just keep going, because it's going to be through practice and repetition and through your own exploration that you're really going to understand Combine to its fullest. Okay, so let's take a look at functional reactive programming at a high level. So what is it? If you think about imperative programming, this is basically telling the program exactly what to do one step at a time. It's easy to step through this mentally or with a debugger and just sort of execute these statements. And you're controlling behavior through if statements and organizing your code into methods and things like that. One thing that arises from this style of code is setting state to control behavior. More on this later. An increasingly common truism of modern development is the nature of asynchronous programming. Much of our work involves performing complex tasks, talking to a network, importing data, and other things that take time. And in order to not block the main thread and keep our apps more responsive, we often need to schedule this work to happen asynchronously and run this code only when the results arrive. So in traditional Swift development, this is often done with callback blocks. So you end up with code that looks something like this. Here we are fetching some data, and then when that data arrives, we invoke this completion callback. So then we can decode the data into some models, and maybe we need to load some images from those models. Again, we want to do that asynchronously, so we have another asynchronous sort of completion callback. And then when that's done, finally, we can update the UI with those images. So this nesting of callback blocks can get way more complex than this. This is just sort of 3 levels of nesting here. And it can introduce subtle bugs, and it also sort of makes it difficult for us to insert new behaviors into the middle of this chain. It also really makes it difficult to deal with error handling. Right now, we're not dealing with any error handling just to keep the example simple, but if an error happens somewhere in the middle of this chain, you want to abort everything else that happens after it, and with this callback approach, it tends to not be so nice in Swift. So asynchronous programming in a traditional sense is far less understandable than imperative code that flows from top to bottom. You can set breakpoints here, but you can no longer sort of follow this from top down. You have to bring your mental model into a state that this sort of completion block is going to be called at some later date. And that also means that you're capturing some variables in the closure itself. And so you have to sort of remember that and deal with memory management the appropriate way. So it's definitely less understandable and more complex than traditional sort of synchronous style top-down programming. Now, reactive programming is a declarative style of programming. You describe the behavior using streams of inputs, which could be anything. Could be button clicks or network responses or gestures or device rotation or anything you can imagine. And those can be internal or external events. You then describe how your program reacts to this input over time. So for the sake of an example, let's look at some imperative code that is taking the value from some shopping cart object, taking the quantity for a given item, and setting that to the text property of a label. So this is how we would update the UI to show the state of a model. But if the model changes, if the user changes the quantity for this item, there's nothing inherent in this code that's going to know to update the text property again. We have to rerun this method. So we would have to have some sort of observer or notification or something like that to tell us that the quantity for a given item changed, and that we need to reevaluate this line of code. In a reactive application, the relationship between these items is declared instead of run when necessary. So in this case, we have something called a quantity publisher. And you don't really need to know what a publisher is right now. We're going to get into that later. But when it changes, it's going to assign the value that was published to the text property on the quantity label. With something set up like this, anytime that publisher produces a new value, it's going to update the label. And we don't need to keep those two in sync anymore. Once we've set it up, it will just work. Additionally, since reactive programming streams don't need to go through the completion callback acrobatics to perform asynchronous work properly, the nature of asynchronous flows can be greatly simplified. So it doesn't really matter where the data is coming from, if it's asynchronous, if it takes time, or if it is more or less just calling methods on data that already exists. You sort of treat it all in the same way in a reactive programming style. So one of the big benefits of adopting a functional reactive style is it helps to make the complex feasible. Sometimes you're working on code that we write in an imperative fashion, and the more requirements we add, the more complex the code becomes, and that is basically a breeding ground for bugs or subtle behaviors that we didn't really want. And so as an example, let's say we were building a movie searching application. So we've got a search field at the top, we type in a search term, and then the user clicks on this button and we need to do something. So we add a search click event handler, and that's going to execute some code, and that code will probably go look at the search field and grab the text value, and then turn around and call some movies API in order to get the search results, and then finally update the UI. Now that code might look something like this. Pretty simple. We have a search clicked method, we get the term out of the search field, and then we call our API. So of course, the simple code, usually works, but there's lots of drawbacks here. And so we ship this and we end up getting some new requirements. So first thing is we need to trim the search term and avoid searching for blanks. So we need to trim any kind of white space around the word. And this is actually pretty common in iOS development. When somebody's using the iOS keyboard, a lot of times it will end up adding a space onto the end of a word if they use autocomplete. So we need to trim all that stuff out. The next requirement is to search as you type. So we're going to need some sort of UIKit, text field change handler to do the search there. And we want to avoid searching unless we have 3 characters, because we're probably not going to get any good results if we're just searching for just a few characters. And then we want to wait 300 milliseconds to avoid searching while the user is typing. So this is called debouncing. And this is just going to avoid hammering the search endpoint with searches that we no longer care about because the user's typed a more precise term and we'll get better results for. And then finally, we want to avoid duplicate searches. So for instance, if the user typed in spider and then waited and got search results and then backspaced and then typed R again to complete the same word again, we want to avoid doing that search again because we already have those search results in place. So these are our requirements that we want now. And so now we have to write some more complicated code. So we have something like this. We've got some new properties at the top. We've got a last search term that we need to keep track of to avoid searching for the same thing again. So this is some state that we need to maintain. Then we have some more state related to the timers. So we need a debounce timer and a time interval so we can avoid searching for something as they're typing. Then we add the text did change method. And this is, the UIKit text field method that we can use. And here we're trimming out any kind of white spaces and new lines and ensuring that the term's length is not 0. And then if that's true, then we'll search for that term. And then down at the bottom, we factored out a method called search for term. And here we need to invalidate any existing debounce timer, then schedule a new one. After that timer has fired, it's going to kick off this block at the bottom. And now we need to do our search. And of course, we need to update the state of the last search term so that we make sure that any future duplicate is skipped. So this code is fine, it works, but what we've done is we've taken a seemingly small contained method and we sort of exploded it out into multiple methods on our view controller, including saving some private state on our view controller in properties. Now, if we compare and contrast this with a solution that uses combine in a functional reactive style, it's important to don't worry about the terms here or the syntax. Don't get hung up just yet. This is basically the type of code that we're going to be writing in this course. And we're going to explain all of these things in detail. So it's okay if you look at this and your eyes glaze over. But basically, we have something called a term subject at the top. A term subject is basically we can just send values through it. So when the user clicks the button or types, we can send a new value through the term subject. So then we take any value sent and we map it, which basically transforms the value. And here you can see we're trimming all the white space and new line characters out of that value. And so what you can kind of see here is that these lines of code, These are called operators. These are mapping almost one-to-one with these requirements that we have on the left. We're mapping to trim out white space, then we filter out any that don't reach our minimum character count, then we debounce for 300 milliseconds, we remove duplicates, and then there's flat map, which we're going to get into later, but basically this allows us to take the output of this sort of pipeline, was what we're going to call it, take the output of this pipeline or this stream and send it to another one and subscribe to that stream. So basically we're transforming the string value for our search term into some search results. Then we assign those search results to a local property on self, and then we store it in something called cancellables, which is just a bit of bookkeeping that we're going to have to do for Combine. So there's a lot of functionality going on here, and there's not a lot of code. I don't want to get hung up on the lines of code comparison because that's not at all important. What is important is the ability to take requirements and transform them into functional code. And next, I want to take a look at two complete examples, one of them that uses an imperative style to do searches, and one of them that uses functional reactive programming. So here we have the imperative example. And so we've got a view controller that's just going to search for baby names. And we have our results that we're going to use snapshots, and we're using a table view controller with diffable data sources. So when we assign new results here, it will update the snapshot and the changes will animate in. We've got our last search term that we're keeping track of to avoid duplicates here. Then we've got our debounce timer stuff. Then we scroll down here and we add our texted change for the text field so we can get called back when any of the text changes. Here we have our search term. We're trimming the characters here and checking for the term count greater than 0, and then calling search for term. Now, if you notice, this search for term in the previous example, we're only trimming the characters here. And so anyone else who calls search for term is going to bypass this sort of requirement. And it's possible to send this into this method. So this is definitely a bug we have accidentally added to this program because we're only filtering it out before we send it to the search term. Then finally, we are in the search method. We invalidate any existing debounce timer to cancel its effects. Then we schedule a new one with that debounce time, which is 300 milliseconds. And then it'll execute this block. If this term is the same as the last term, we can just skip it. And then finally, we call api.search. When we get the results, we store them in the last search term, store results here, and it updates the snapshot. Okay, so this code definitely works, and it models the example that I showed in the slides. And we can go ahead and run it. And so we're searching for baby names here. So if we just sort of type a few characters, and it's got essentially a fake API, so it takes a little bit of time, and now we can get some results for the search term. And if I continue to type, we'll get those results. And you can see that it is waiting. So if I type another character, it takes a second for it to actually do the search. Okay, so that's the imperative example. And let's just contrast that with the functional example. It's exactly the same demo, but what we have here is we're importing Combine at the top. And we no longer need the local properties to keep track of the last search term or the timer, because that's just sort of intrinsic to some of the features of Combine. What we do have are these Combine specific things, cancellables, which is a set of any cancelable. And this is basically a super common pattern that you're going to be doing in basically anywhere you use Combine. And this is to keep track of all of the subscriptions for memory management in Combine. And you need to store your subscriptions here. And when this goes out of scope, it will call cancel on everything inside of the set, and therefore cleaning it up. Then we have something called a term subject, and we're going to get into subjects later, but this produces values of strings. And so what we have here is where we're connecting the UIKit world to the Combine world is by sending values through the subject. And so what we're doing here is in the text did change method, we are taking this. In fact, we no longer need to trim it here or do the count there. Need to fix that. So we're just going to grab the term, call search on it. And then we need that to go inside of here. So we're going to map this to $0, trimming characters in, white spaces, and new lines. So that fixes that bug. So basically, when we call search for term, it's just going to send that value through the term subject. So it's basically just, okay, we have a pipeline and now we're sending a value through it. And subjects are often used to sort of bridge between the functional reactive world and everything else that isn't functional reactive, like UIKit. And so this is a good way for us to, adopt Combine for the entire world. We can use it for a small part and then send input into it. So basically this is how we're doing that. And then we map this to trim all white space. We filter out any values that don't match our minimum character count, which in this example is set at 2. We could change it to 3. So what that means is that any values that we get that are less than that are just going to get skipped completely. It's not even going to continue any further down the chain. And so we actually have the opposite subscription here. So this is filtering things that are less than. So if it doesn't get caught in this stream, it'll get caught in this stream. And then we assign that basically to an empty array so that it'll end up clearing the results. Then we have our debounce, remove duplicates. We've got our flat map so that we can basically take the output of this stream, send it into another one, and subscribe to the results of this guy, and assign that to results on self, store in cancelables. And now we can see that basically everything is just set up ahead of time. This function, configure search, is set up in viewDidLoad. And this is going to be a common pattern that you're going to see when doing functional reactive programming, is a lot of the behavior is set up ahead of time, and then you just let it play out. So I encourage you to explore both of these examples that you'll find attached to this module so you can sort of get a sense for how these two styles are different. And then lastly, just a couple of notes on this. Don't get hung up on the syntax. I think it's easy to look at the syntax of this and sort of roll your eyes because there's a lot going on here, especially when you get to flat map, because this is not a term that really makes any sense in English. It requires you to have some understanding of functional programming. And once you do, it makes sense and is very useful. But until you do, I think it's really easy to just say, I don't like the style of programming because this doesn't make sense to me. And so my goal throughout this course is to make this type of code make lots of sense to you. So we'll cover exactly how all this works later, but this gives you a taste of what programming with Combine is like. In reactive programming, you'll work with streams. Now, streams are essentially values over time, and they're often represented like this. Here you can see a stream that is producing button taps, and time here flows to the right. Every time the user taps on a button, a new value or event is emitted on this stream. If you wanted to model dice rolls as a stream, you'd have a stream of integers that might look like this. Sometimes streams can complete, in which case they'll denote an ending line like this. Other streams might produce an error, in which case there's an indication of an error on the stream. And in both of these cases, if a stream finishes either by ending successfully or by producing an error, no further values will ever be sent on that stream. It's a good idea to start thinking about the various streams and events in your own applications and try to think of them in this model. So in our search example, we had streams of search terms over time. We had a term subject that was producing strings, and each one of those represented the search term. So those streamed values over time might look like this. We also modeled the search results as a stream, and those search result streams might look like this. Here, each value is actually an array of results. It's also important to note that some streams produce just a single value, some produce multiple values. Some streams never complete, but some do. Some streams can never produce an error, but some might. And so all of these things are really important to grasp. But as we're thinking about things in terms of streams, be thinking about this sort of syntax for visualizing them. These are called marble diagrams. So let's take a little bit more concrete look about what marble diagrams are. Marble diagrams are a common way to visualize functional reactive pipelines. These diagrams may look a little confusing at first, but once you get used to them, it does make it easier for you to quickly understand what the various functions in Combine do. A good example of this lives at rxmarbles.com. Now these are specific to RxSwift and RxJS, but because Combine and RxJS and RxSwift are so similar, most of these are going to be very familiar in Combine. And there are some differences with Combine and RxSwift, but for the most part, we're just going to take a look at the marble diagram as a structure, and I'll walk you through a couple of these examples so we can see how it works. So I mentioned last time that each of these is a stream of events over time. So you can see that this top one is producing 5 values. And let's go quickly take a look at probably the easiest one, which is going to be map. Okay, so this top stream here is producing 3 values and then completing, as you can see with this vertical line. And with these marble diagrams, you can drag around these marbles so you can sort of see what it does to the underlying stream. So this is what's called the upstream publisher. And then this in the block here is called an operator. And it operates on publishers, or it operates on streams. So what we're doing here is we're using the map operator, and we're passing in this block, which is saying, take whatever you get, multiply it by 10, and produce a new stream with the output. So you can see that this first value gets multiplied by 10 and is emitted on the stream below. Again, we have 2 is multiplied by 10, and now we get 20, and 3 is multiplied by 10, and we get 30. So this is a map operator. It's just like map for array, and instead of producing a new array, you produce a new stream of values. So one of the reasons why it's important to take a look at this sort of syntax and zero in on just one operator at a time is because these are like the lingua franca of Combine. These are kind of like your ninja moves, and the more you know, the more you can do with Combine. And so we're going to start off with a few easy ones, but throughout the course, you're going to learn more and more. And there are some that we're not even going to touch on in this course at all, but I would encourage you to just pick one and take a look at it and play around with it and see if there's examples where you might find that useful in your day-to-day work. Let's take a look at another one. This one is called merge. Now merge takes 2 upstream publishers. As you can see here, we've got 2 of them above this block, and both of them have to have the same exact value. So you couldn't merge an array of strings or a stream of strings versus a stream of integers. They have to be the same type. So the types have to agree. And in Combine, the error types also have to agree. So this is something that the type system can guarantee for us. But as long as we have 2 publishers of the same values, we can merge them together and get one stream or one publisher of the merged values. So here you can see it's taking 20 and 40 off the first line, and 60, then 1, then 80, then 100. And you can see if we just drag this a little bit forward, you can see what the resulting behavior is going to be. Now it's important to note that the output of an operator is always another stream. So this is the inherent nature of them being chainable. Let's take a look at another example. This time we're going to look at first. So first operates on a stream, and it only gives you the first value and then completes. So if you notice, we've got a stream up here that's producing 4 values, then completing, but the downstream publisher doesn't care about the rest of them. And so it can prematurely complete because it knows it already has a value. And if I drag 2 over here, you can see that it completes with the value 2 because that was the first one it got. We also have a last, and this one is interesting because you can see that even if we emitted all 4 of these early, as long as this event right here, the completion event, hasn't fired yet, this thing is still waiting. So it can only operate when it knows the upstream publisher has completed. Because if you think about it, if 4 was way over here and it completed at 3, well, that's not the last element. It was just, there was this sort of lull before it got the 4th one. So some of these operators are going to work on streams and wait until they complete, and that's also really important. Here we have debounce. Now, debounce is something we talked about when we did the search example. And so what's happening here is you can see that there's some sort of time value that's being inferred by the distance between these elements. And so what's happening is we have 1, but it doesn't get emitted immediately. It waits to make sure no new values are coming in. If I bring 2 closer to this, notice how 1 disappears. That's because it basically reset the timer and now is waiting for a quiet period before it emits the 2 downstream. So this is basically really useful, and is functionality that as we saw in the previous demo, that would require you to manage your own timers and completion blocks and stuff like that. And this is just a first-class operator in Combine. Let's take a look at a couple more. Let's look at count. Count, again, is one of these operators that is going to take an upstream publisher, wait until it completes, and then emit a single value with how many of the values were, matched this block. In this case, obviously, it's filtering counting only the ones that pass the block, but you can see that it gives you a single value and then completes. So there are publishers that are sometimes called one-shot publishers that just fire a value and complete. And there are other publishers that sort of long-lived that they might, for instance, if you're waiting for a button tap, that one's just going to never complete because the user could tap the button at any time. Okay, let's look at 2 more. One of them I want to look at is called Zip. And Zip basically is going to pair elements together. So we have, again, 2 upstream publishers. So the first one emits a 1 and nothing happens downstream. The second one emits an A, and now that it has a value from both of these, it's going to zip them together and give you the pair. So it's basically just taking those pairs as they come in. Again, here we have a 2, and then once a B comes in, now we have another pair, and I can emit 1. If I flip these around, notice that it just waits for there to be a pair from both of them. So in this case, we have C and D, but neither of these have a matched pair yet, and so nothing is emitted downstream. But then 3 comes in, and it gets matched with C because it was waiting for a pair. And then 4 comes in, and it gets matched with D, and it was waiting for a pair. Now, another interesting thing about this is 5 is never matched with anything. And if you see why, is because this stream completed without providing a value. And Zip will ignore any unpaired values. And so as soon as this one completes without providing a value, it knows that there's never a chance for it to, there's no reason to keep listening on the first stream. The second stream's already completed. But the first stream could complete while it's waiting on the second one. Now it's dependent on that second one because it's waiting on an element here. So Zip might be useful if you have, let's say, 2 API calls to make, and you only really want to continue when they're both there. And as long as if you don't care the order in which they arrive, you just want to make sure, okay, fire this first one, now fire the second one, and when they're both done, give me the tuple of their results. And so you can see that all these are down here are just paired, and in Swift that comes in as a tuple, where the first element or the .0 element of the tuple is the value from the first stream, and the .1 element of the tuple is the value from the second stream. And in this case, you can see that the types don't necessarily have to match up because it's emitting a new type of value in the downstream publisher. So I don't want to overwhelm you with learning all these different operators. There are lots of them, and most of them you will not use, at least on a day-to-day basis, but there are going to be ones you come back to time and time again, and it's really important that you understand how these operators are working under the hood so that you can use them most effectively. So make sure you bookmark this site, RxMarbles, and if you ever have a question about how an operator is behaving, see if you can find it in here and come up with a marble diagram so that you can sort of play out exactly how these values are working. Okay, so that's enough theory. Now we're going to get into the nitty-gritty of Combine, and we're going to start by looking at the basics.